All right, so this next lesson, what I'm going to do here is kind of go through a real life example or an application of slope. So for this example here, I'm just going to read it off here. So in order for a ladder to be considered safe when leaning against a wall, it must have a slope between 15/2 and 12. So part A here. So if the foot of a ladder is 3 feet from the base of the wall, what is the maximum minimum height it can? Okay, so start off here. What I'm going to do here is just kind of draw a diagram of what's happening. So let's just say that that's the wall and this is the ground. And we have a ladder that's leaning up against the wall. So the ladder is in green. Um, and from the information given here, you can see that the foot of the ladder is 3 feet against the wall. This distance here is 3 feet. And we want to know what is the maximum minimum height. We call this uh, distance actually y because it's up and down. Um, okay, so this is a diagram of the ladder. Okay, so in order for the ladder to be safe, it must have a slope between 15 to 12. All right, so 15/2 is, well, as a number itself, it's 7.5. It's a decimal, but so basically this gives us a range of what the slope of the ladder can. So in order to answer this question, then find the maximum minimum height, we're going to do this in two separate calculations. All right, so for example, let's just say that this is a sketch of the ladder having a slope of, say, 7.5. So add that in here. So let's just say this is the diagram of slope. Is 7.5. Now, if I wanted to draw another scenario, the slope 12. So a little bit of review from the previous lesson. Is this ladder going to be steeper or flatter? All right, so think that over, right? Slope of 7.5 looks like this. Now, if I have a ladder with a slope of 12, it's actually going to be something like, remember, the bigger the number, the steeper the line. Again, this is still like 3 y. All right, so to answer this question, we actually got to do two separate calculations. So I'm just going to show you how to do that. So for this first one here, I have a slope that's equal to 7.5. So slope is equal to 7.5. Actually, you know what? Write it as write it as the function instead. You'll see why in a second. All right, so the slope is 7.5, so in other words, 15/2. Right, and remember that this is, again, the rise. So to answer this question, to figure out the height of y here, what we need to do is set up an equation. So the equation that I'm going to set up has to do with the slope. So slope is 15/2, which is rise over run. So in other words, 15/2 is going to equal. So in this diagram, the rise is the distance up, right? So that's y. And the run is the distance across. So I'm going to sub in 3. So it's as simple as that. We're going to set up this equation and then solve for y. Okay, so to solve for y here, remember whenever you have fraction equals fractions, let's multiply. So that that's the case here, we got 2 times y equals 3 times 15. So 2 times y equals 45. Then to solve for y here, I'm going to have to divide both sides by. All right, so the answer here would be 45/2, 22.5 feet. So that would be actually the minimum height of the wall. The slope 7.5 is going not as steep as slope of 12. All right, so for this one here, to calculate y, slope again is equal to 12. Now, whenever you're dealing with the slope of a whole number here, we want to write it as a fraction. So I'm going to write this as 12/1. So the equation that we're going to set up here is 12 rise, which is y, run is 3 feet. And to solve for y, again, I'm going to cross multiply. So 1 times y is y. That's going to equal 12 times. So that is going to equal 6 feet. So, or yes, so the minimum height is going to be 22 feet. Is going to be at least 22.5 feet. Maximum height here is 36 feet. So that kind of makes sense, right? So if this ladder here was like any flatter, it could possibly, likewise, if it was any steeper here, if it was too close, then it could tip down this way. So, anyways, that's the yes, that's how you find the minimum and maximum. So next up, this is part B here. So if a ladder reaches 20 feet up the wall, what is the maximum minimum distance the foot of the ladder can be away from the base of the wall? All right, so what that's saying here again, instead of given the distance from the base of the wall, this time what we're going to be dealing with here is fixed height of 20 feet. Then we want to figure out what x is. All right, so again, we have two different slopes, so we're going to do two different calculations. And so again, the first slope here, let's just say is equal to the 7.5. And that as an equation was 2, or sorry, as a fraction is shifting over 2. Again, this is my rise over the run. So if I set up the equation here, I'm going to get 15 over 2 equals. My rise this time is 20, my run is x. Right, and I want to solve for x. So in order to do that, cross multiply here. So I got 15 times x equals 20 times, or 2 times 20. All right, so 15x equals 40. Now if I divide both sides by 15, x is going to equal. Now this I can reduce to 8 over 3, which as a fraction is approximately, so 8 divided by 3 is 2.7. Okay, so that is going to be the farthest it can be. So obviously if I work out the other one, the slope of 12, it's going to be a steeper ladder, it'll be closer. So the other option of the situation here, get a steeper ladder. Right. Again, this is what we're trying to find x. That's fixed height of 20 feet. Right. So this time my slope is equal to 12. Right. Slope had to be between 15 over 2. And, all right. So I'm going to do the same thing here. Sub the equation. And again, this time slope is a number. So if the slope is equal to slope equal to 12. Now, if this is a whole number here, I'm just going to write it as 12. This is equal to the rise we run. So the rise here is 20. Run is, all right. So again, to solve this, cross multiply again. And we get 12 times x equals 1 times 20. It's 20. All right, so just divide both sides by 12. And this reduces as a fraction. This is equal to 5 over 3. Yep. And so this is equal to 1.7. Right. So these are your two distances, right? So the maximum distance from the wall it can be is 2.7 feet, whereas the minimum distance is 1.7 feet. All right, cool. So this is just, yeah, so this lesson here is just basically you're given the slope, and this time we're trying to calculate either the rise or the run. Calculate the rise here, part A, the run in part B. So it basically comes down to a simple equation. You're going to have fraction equals fraction. Then to solve those, you're going to cross multiply. All right, guys. Yeah, this is a fairly short lesson. That's it.